Hello everyone. In this tutorial what we are going to learn is norm X and scale X. The reason we are going to learn this is that my students have asked me to do a video on it, and I hope this will probably take us 15 minutes. I have to be a little bit quicker so that it can take us maximum of 15 minutes. And the reason for this is, there are certain devices that gives analog data. For example, temperature control, tank level measurement, pressure measurement, flow measurement, and motor speed feedback. All of this give analog signal. And how can a PLC, convert this into a discrete information which we can read? For example, temperature in degrees Celsius. How can we read that? Or maybe tank level in meters. So what we are going to do is to use norm X to normalize, the analog sensor input or the analog input. For example, in voltage 0 to 10 volts, or in current from 0 to 5 volts. All of these measurements that I've called the voltage and current are analog values, continuous values. So how can this be turned into discrete value? For example, in degrees Celsius, if it's in measurement, sorry, if it is in temperature. And PLCs cannot read analog values directly. PLC, it's about discrete. So what we are going to do is we are going to use the norm X to normalize, the input data, and that is the input data which is either in voltage or in current. So the norm X would normalize it into for example, between 0 and 1, and then the next one that does the final normalize, does the final transformation will be the scale X, that probably, for example, takes the output from the norm X and convert that one into the final output, for example, in degrees Celsius, or maybe in certain values or scales that we can read. So what I'm going to do is quickly I will pick let me just pick the norm X here. Let me pick the value straight away, because this is just about norm X. The next video this is just about norm X and scale X. The next video we will go a little bit higher to create a project that will use both the norm X and scale X. So I'm not supposed to. I'll drag and drop it here. Good. So the norm X will just normalize the value, the analog signal. So here the PLC, what the PLC can actually read is discrete or digital values here, discrete values. So the PLC readings, it's from 0 to 27,648. And what type of data is coming here? It's the PLC is going to use integers here, that is whole numbers here, and this bit here, the value here which I've just clicked here, is supposed to be the data coming from the analog sensor. And the PLC uses this IW64 which is a value between 0 and 27,648. Well, now I've got a tag here. Once I gave the IW64, I've got a tag given to the value here. You can decide to change the tag name. If you want, you can right click and define, rename the tag if you want. So I can say, I will say maybe raw data or anything like that, and I will change the name. That is good. And then here it's going to be the output. So I can say output, I will say output, output 1, and I will right click and just define, and I will say global memory. It's fine. So what we have done here is that, the PLC will convert whatever input that is coming here. That is the raw data. Whatever input, either it's maybe 5 volts, 6 volts, 7 volts, up to 10 volts, and the minimum being 0. The minimum being 0 volt. It will convert this analog signal into something, for example, here I'm going to change here it into real value, and here, the output. What the norm X does is that it changes whatever input, it normalizes whatever input that comes to it to a value between 0 and 1, as you will see later. So whatever value that comes here is going to be normalized into to between 0 and 1, and that will be the output here. Now this output will now come to the value here. That output will come to, so the output from the norm X will come to the value or the input of the what is it called? The value is the input, as it is also here. It will come to the value of the scale S, and this scale S will now also scale whatever value that comes here from the output here into something, for example, like maybe degrees Celsius or anything. And the value here is, the minimum here is 0. We can say 0 or and 100%. You can put it this way, 0 and 100%. And what value is coming here? Actually, remember the output here is real. It's the output here correspond to the number here. Let me drag this here. The output here is real number, and the input here is integer. So the output here is real number. That means whatever comes here this side will also be a real number or real value here. And then I think there is something wrong here. Let me just check. Let me try out something here. Okay, so yeah, it's fine, unless I change. So whatever we wanted to come out of this place here, whatever we wanted to come out of this place here should be, for example, if we want it to be an integer or real number, then it's going to be an integer, or we can put an integer there, but so let me just put something here. Let me put something here. So what I'm going to put is, let me say final output. And then I will define this tag. And that also, I will say it's global memory. So I've got that one here, and this is it. So real number into integer. You can also say maybe real to integer. It depends on, what you've been given. If it is temperature, then I guess if the final output we want to see here is temperature, then we have to use integer. If the final output we want to see here is maybe a tank level, which is maybe in meters, which means we can have maybe 1.2 meters, 3.4, and so on. Then that means the final output here will be, for example, in real numbers. So that is it. Now, what I want us to do is, I want us to, test this. I want us to test this here. And to test this, I want us to go straight to the compilation just to compile and see if there isn't any fault in the language I have used here. I think everything is fine, 0 errors and 0 warnings. So now let me go and simulate. So I'm going to simulate it here, and after the simulation we will check the program to see if it works all right. Sorry. My PLC is a legacy type. That's why you can see all of that there. So I will upload, and then I will upload. So I'm going to switch it on. It is on, but what I want to do is that I want to open up this and download the sim, the step 7 sim, so that I can use it to run the program. So it's going to take a bit of time, but we will get there. A bit of time, but we will definitely get there. We are still waiting. It's going to get there. It's taking a bit of time. So we will get there soon. We will get there soon. Maybe a little bit more, a minute or two. Yes, we've got a green text, so it's now good to go. And then I will bring this up. And good. So this is what I want. This is what I want. Let me just drag this here and bring this back up here. And then what I will do is I will just show it here, and let me also minimize this one here. So what I'm going to use is I'm going to use this to see what happens here, the conversion. So whatever input comes here, and I'm going to use the input from here. For example, whatever input that it's generated is going to be converted into a value between 0 and 27,648, and this value will further be converted into the final output here. So now the value here, the input from the sensor is 0, and we can see an output here 0. So and that output is here as 0, and the final output is 0. So now let me increase this a little bit here, and you can see whatever value from the sensor. So the sensor's value has been converted to 3,997, and that value here has been converted, the 3,977 has been converted to 0.11567,415, and a whole lot there, a whole lot. And that output is here, and the final output. So if this is temperature between 0 and 100 degrees Celsius, then we have this value of 144.5 correspond to 14 degrees. Now let me increase it a little bit here, and you can see it's now 0.412, and that is here as the input for the scale X, and it's 41 degrees Celsius. Now let me take it a little bit, and you will see it's now 0.51, and that is an input here. It's been converted to 51 degrees Celsius. So if we go on here, we will have, you can see 63 here. If we keep on here, 80 something here. If we keep going, 90, and if we keep going, now it's 103. The reason I brought you to 103 is that this is an overflow, or overrange. This is overrange, and that can detect maybe a fault. So if we go beyond our range, that probably will mean a fault. We can also bring it down here, and we can have an underflow. It's minus here, so minus 54. So that could also signal a fault there. So this is how we can create this, and this is the first version. Next time we will probably put some program in there and see. Thank you very much for watching, and thank you for your time. So this is the first part, and look forward for the second part.